Hello everyone. In this lesson, my main objective is to teach you exponential functions. So the relationship of the form written as y equals a power x, we call that as exponential functions. Now, as you can notice, x is in the exponent position. Now, what is an exponent? It's the other names for your exponent is index or power, a power x. You can read the equation as y equals a to the power of x. So since x is now in the exponential spot, or as x is working as an exponent to this equation, we call these as exponential functions. That's all. So the other vocabulary term that I want you to keep in mind for these kind of equations is something called as asymptote. Asymptote is nothing but, imagine that it's like a wall that doesn't allow the graph or your equation line curve to pass through it. So it's just basically blocking it, okay? And then we also need to remember anything to the power of 0. If your exponent power is 0, the answer is always 1, no matter what the x value is, right? So now let's see. In this case, I'm using an example, something called as y equals 2 power x. Okay, so this is what we are going to take a look at. Now, I created a table because anytime you want to graph something, you need to create yourself a table, get the x and the y values, and all we are going to do is we are going to take it and plot it on our graph, right? And then we are going to connect the dots and see how this looks like. All right, so when x is -3, if you substitute into your calculator or if you know mental math, it's fine. You need to know that this is nothing but 1 divided by 2 power 3, or nothing but 1 over 8. Okay, I'm not going to go deeper into the index laws, but if you have time, you can review the index laws. All right, so I'm going to get these values straight away. That's 1 over 8. That's going to be 1 over 4. 2 to the power of -1 can be written as 1 over 2. Now, when x is 0, right, 2 to the power of 0 is nothing but 1. Remember, I told you to recollect that rule. If the power is 0, you will end up with 1. When x is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. All right, so now let's go ahead and plot that on your graph. So what I'm going to do is I'm going to do a bit of marking here. So x is 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, right? And then we are also going to put, let's see if I can do, let's treat, what are my maximum y values is going all the way to 1/8 to +8. So okay, that's fine. So let's do 1, 2, 3, 4, 5, 6, 7. Maybe that somewhere over there, that would be 8. All right, so when x is -3, so I'm going to put the dots with a different color, maybe violet. Okay, let's see. So when x is -3, it's 1/8. So 1/8 would have been, what's the decimal value of 1/8? 0.125. So somewhere very, very close down there. When x is -2, 0.25, 0.5. And then when x is 0, that's 1. And then when x is 1, you are getting 2. When x is 2, it is 4. When x is 3, it's 8. So all the way up there. So now I'm going to draw my curve connecting these points. Hold on. Let me use a different color so it's clear for you. Let's do green. There we go. So as you can see that the curve is going up in this manner. So what can we conclude or what can we say? Now we need to identify a few things here. So what are the significant features of this curve? What do we notice? We notice that the y-intercept. First of all, let's talk about your y-intercept. Y-intercept is right here. It's touching the y-axis at 1. So you write this as 0, 1. So your y-intercept is at 0, 1. Now, as the y value is when is it increasing? As the x is increasing, right? The y value is increasing exponentially. That's what it means. So the value of y is always greater than 0. That's one thing that you are seeing. Okay, so the value of y is always greater than 0. What's the other feature that we are noticing? As the x decreases, though, you see that the y keeps going towards as the x decreases. Yeah, as we go on left, as the curve goes left on your x-axis, that's what decreasing means, right? So we notice that as x is decreasing, what is happening to y? Y starts to get closer to x-axis, but it can never pass beyond that. Okay, it doesn't even get closer to 0. It never approaches it. It just stays as if it's gonna touch, but it's never gonna touch. Okay, so y gets closer but never reaches 0. Okay, y gets closer, keep this in mind, but never touches the x-axis. So now a new term is introduced. So basically, since the x-axis is not allowing it to pass through it, this becomes your y, it's called your asymptote. And the equation of this asymptote is y equals to 0. So these are some of the significant features that we are discussing. So this has a horizontal asymptote, right? And that is, which is your x-axis. And equation of that asymptote is y equals 0. So these are some of the important significant features we are noticing. And then finally, one more thing. I talked about x decreasing, but I didn't talk about what happens when x is increasing. So when x is increasing, as we are going towards the right side on your x-axis, what do we notice? We notice that the y is going to become so large. Okay, so y is increasing exponentially, so big. So big. So those are the basic observations that we made about this graph. All right, guys, so let me recap quickly what just happened. So we noticed that this is an exponential function because the x is in the power spot. Okay, it's not next to 2, but it is in the power spot. So because the x is in the power spot, right, we call it exponential function. Fair enough. Then we we created our own table. So we basically gave some input values to x, starting from -3 all the way to +3, and we figured out what y is by substituting the x value into the equation. Once we got that, we have plotted the curve, we plotted the points on the x and y plane, and we connected the dots, and we have realized that it's going to be a curve. Then we have concluded certain significant features, and the features is, where is this curve touching the x and y axis? So because we need the intercepts, we need to talk about the intercepts. It never touches the x-axis, and that is why we call the x-axis as our asymptote. The curve looks as if it's going to touch. As the x value decreases, the curve is approaching the x-axis, but it's never touching. So that's a new term that we talked about. Asymptote is a line that doesn't allow the curve to pass through. Then we talked about the y values. The y, we never ever got negative y values. So we can confidently say that y is always greater than 0. And we notice that as the x decreases, y gets closer. We talked about that. And then finally, as x is increasing, as we move to the higher values of x on the right side of the x-axis, we notice that the y has exponentially gone up. And that's why these functions are called exponential functions. So as the x increased, the y values have gone up. So I hope this video is helpful, guys. If you need further clarification, check out the other examples that I'm going to add into a different lesson. But I hope this is clear and you're much confident after listening to this video regarding exponential functions. Thanks for watching.